Okay, I will explain that definitions in this diagram. So for the first activity A. So activity A, earliest start is 0 because A is the first activity. Earliest finish is at week 4 because activity A takes 4 weeks to finish. And activity B, so earliest start at week 4 because it depends on its predecessor is activity A. So it depends on activity A before B can begin. Earlier finish is at week 10 because activity B takes 6 weeks to finish. 4 weeks start and plus 6 weeks to finish, and earliest finish is at the week 10, and so on. So you have to understand this definition in this diagram. Okay, this diagram shows latest start and latest finish element. So first, you must know which path is the critical path. This is the critical path of this project. So this critical path cannot be delayed. Cannot be delayed. So latest start and latest finish are fixed. As you can see, latest earliest start, earliest finish, latest start, latest finish are same. However, this activity C, F, and H, these are non-critical path. So it means we can delay these activities in this section. Okay, look at this section. So why activity C and F, activity C late start 22, activity F late start 35. So it is because activity G depends on activity F and C. So when activity G early start and later start at week 30, so activity F must be later start at week 25. So meaning that later start and earlier start at 30 minus 5 weeks. So for activity F, later start is at week 25. So for the activity C, later start is at week 22. So it depends on activity F depend on C. So C must finish first before we can do the activity F. So 25 minus 3, then we got 22. So for the latest finish, if activity C latest start is 22, so we plus 3, and we got latest finish 25. So it's the same with the activity F. So when activity F latest start is at week 35, so you must plus 5, and we got the latest finish at week 30. So for this section, activity H takes 2 weeks to finish. So latest start at week 33 because J depends on H. So when activity J must start at week 35, so the latest start for activity H is at week 33. So 35 minus 2 weeks, and we got latest start at week 33. So latest finish 35. So we plus 33 plus 2, and we got latest finish at week 35. I hope you understand this definition of earliest start, earliest finish, latest start, latest finish. Try to understand this diagram. Okay, so this is how to calculate slack or float. So we just list down all the activity. So we put the late finish, earliest finish. So for the calculation of slack or float, so we just calculate the non-critical path or non-critical activities, which are activity C, F, and H. So this are the non-critical activities, activity C, F, and H. So if we look at this table, activity C, the late finish is at week 35, early finish is at week 7. So we have extra 18 weeks so that we can postpone or delay for the activity C. The maximum is 25. So within for this duration, we can postpone or delay only for this activity C, and we can also within this duration we can postpone and delay only for this activity F, and within 1 week we can delay or postpone for the activity H. I hope you all can understand this calculation. So with this we can plan proper all the activities without disturbing the project completion. Okay, this is probabilistic. So this is the PERT method that I explained earlier. So this PERT method just put optimistic time, most likely time, pessimistic time. So the need for these elements is to cover the probability and uncertainty. For this lecture, we skip this part because it is too advanced for you. So I will not teach the PERT method. So we just focus on critical path method for this lecture. But you can see the slide just for your information. So reducing project completion time. Project completion time may need to be shortened because sometimes we have different deadlines. So penalty clauses need to put resources on a new project, promise completion date. So reduce project completion time is called crashing. So crashing a project needs to balance, shorten a project duration, and how to balance the cost. So crashing a project requires you to know crash time of each activity and crash cost of each activity. This is how we can reduce the time of a project. For example, activity A, normal time 4 weeks, normal cost 8,000. So we can crash time 3 weeks, meaning that we can reduce 1 week and it will cost 11,000. So reduce cost per week is 3,000. This is how it works. So crashing costs are considered to be linear. Look to crash activity on the critical path. Crash the least expensive activity on the critical path first, based on cost per week. So as we can see, the least amount, if we want to plan how to crash some of this activity, please choose the least expensive one. So for example, crash activity 1 from 3 weeks to 2 weeks. So it costs 1,000. Crash activity J from 4 weeks to 2 weeks. It costs 2,400. So recommendation crash cost total is 7,400. So question, will crashing 5-week returns more in benefit than cost? Is it worthy? Is it can benefit the project? Okay, that's all from me. Try to read and try to understand this topic. So please let me know if you have any question. Okay, thank you.